Once again, I think we'll go with the same chapter that is programming of 8085. I think we'll continue with branching group of instructions. In the first session, we have already seen jump and call. Okay, now let's see. I think in the call instruction, you have already seen that it is related to subroutine. Okay, and in subroutine, we are having the last instruction as return. So let's go with return instruction. Okay, at the end, I think we will be having one program to explain you the return instruction. Unconditional return instruction. There are two types of return instruction: unconditional and conditional. The program sequence is transferred from the subroutine to the calling program based on the specified flag of the PSW. Now PSW, I think what is the full form? Processor status word or program status word. Okay, now status in the sense, I think everyone understood that status means flag. Okay, they are talking about flag. So I think you already know that we are having pairs. Okay, like HL pair. Okay, then VC pair and DE pair. Okay, there is one more combination known as I think A and F. Okay, A for accumulator and F for flag. So this combination is also known as PSW. So PSW is also known as register pair, which is accumulator and flag. So I hope you understood. The 2 bytes of the top, the 2 bytes from the top of the stack are copied into the program counter. At the program counter, execution begins at the new address. In this instruction, stack pointer is incremented by 2. They belong to register indirect addressing mode. All the instructions are 1 byte. Now don't worry, I think right now that means it will come to the main program, from the subroutine to the calling program or to the main program. Okay, now let's understand this. RET, that is return. They don't have any address, that's why they are 1 byte. Return from subroutine. If you want to bring your control back from subroutine to the main, then return instruction is used. I think it is very clearly written, from subroutine to main. Okay, and call is exactly opposite, from main to subroutine. The contents of memory location whose address is specified in the stack pointer are moved to the lower order byte of program counter. So that means the values will be given to the program counter. The contents of the memory location whose address is one more than the contents of stack pointer move to the higher order of the program counter. The contents of the stack pointer are incremented by 2. Okay, then when we will see what do you call program, that time it will be more clear. Stack pointer, can you see, whatever the address of stack pointer is there, that will be given to the program counter, and stack pointer will be incremented or decremented. I think it will be decremented by 2. This has to be decremented. Okay, now let's take conditional return instructions from subroutine. If the condition is true, then the actions specified in the return instructions are performed, otherwise the control continues sequentially. I think we have already seen jump instruction, so just replacing J by R. RC, that is return on carry flag will be set. RNC, return on no carry is 0. RZ, return on return if 0 flag will be set. RNZ, that is return on no 0 flag will be 0. RPE, return on parity even. RPO, return on parity odd. Okay, then RP, return on positive sign flag. RM, that is return on minus. So I hope you understood all the instructions, but let's go with the detail. So I just given you a program. I think we have already seen this program. When the control is coming from the I think right now we are here, we are at the subroutine. This is your main program. So can you see this before execution part? Let's try to understand the before execution part. So right now, can you see the program counter is at 1 minute. So program counter is at D003. Okay, program counter is at D003. Now why it is D003? Because after this instruction, I think this is 1 byte instruction. So after this instruction, program counter will hold this address. And stack pointer, can you see stack pointer is pointing to E000H. Okay, E000, because I think, do you remember in the call instruction everything was stored, I think they already given the work to the stack. So this is nothing but a stack. Okay, so stack is holding this data. So can you see, and who is protecting that data? Stack pointer. So whatever, I think whatever is there on the stack, that is the this is the address C060. So what happens, I think from call instruction, 1 minute, I have to drag it. From the call instruction, what happens, it has gone there, okay, to this side. But when it when you see the return instruction, it will come back. But when it comes back, it has to start from C006 onwards. That's why program counter is at what position right now? D003. Okay, and when you will come back, you have to start from where? C006. So what happens, you know, whatever the value is there, I think stack pointer is having C006. So what it does, you know, stack pointer gives this value to the program counter. Can you see? So whatever the value is there in the stack pointer is right now, can you see, it is pointing here. So the stack pointer's content will be given to the program counter. And remember that how they give the contents. So there is a definite way, like program counter is a 16-bit. So program counter higher order and program counter lower order. So this is higher order and lower order. So remember that first lower order is given to 06, will be given to this, and then the higher order. Okay, then higher order is C0. So here you will be getting 06. Okay, and here you will be getting 0. So ultimately program counter will hold what value? C006. And stack pointer, can you see, stack pointer has to release the value. So it will just remove the values from the stack, and stack pointer was initially at this position. Now can you see the position has been changed. So stack pointer is incremented by 2, because initially it was at E000, E000, now it is at E002. Can you see? So the new values of stack pointer is E002, program counter is C006, because this address is coming from where? Stack, and stack pointer will be incremented by 2. So how to explain, suppose in your vivas, if they ask you about what is return instruction, so you should say that return instruction is exactly opposite of call instruction. In return instruction, whatever is there in stack is given to the program counter, and program counter will take the contents of the stack. Okay, because if program counter doesn't reaches here, because this is an incomplete program, okay, because the control is already transferred there, and again it will come back from here to here. Okay, and this remaining 2 instructions are not done, so it has to execute this 2 instruction. Okay, for that it is coming back. Okay, once it comes back, so what happens, whatever the, I think it has to start from here. So it will take this address, program counter, and when it gives this address, the stack pointer is incremented by 2, because these 2 values are already given to the program counter. So stack pointer will take this value, new value, and program counter will take the value which is there in the stack. Okay, now this is about unconditional. But suppose instead of this, if you write RC, that means return on carry. Suppose after making 2's complement, after removing 2's complement, if you get a carry, then only it will return, otherwise it will continue. I hope you are getting. Okay, if this condition is not false, that means if it is if this condition is false, then it will continue, but if it is true, then it will come here. Okay, it will work. So you can if you are having carry 0, that means these are the conditional return instructions. Okay, So if your condition is true, then only it will come back. If your condition is false, then it will continue. Okay, that's why most of the time if we don't write conditional return statements, we write most of the time return only, because we want that the when it goes from the main program to the subroutine, so from subroutine it should come back. Okay, so if I want to show you, I hope in small classes you might have seen about interrupts. So it is similar to that, like you are doing some program, okay, you were executing your main program, then call instruction comes, so you have to go to that subroutine, you have to execute that part, you have to come back. Now when you want to go there, that time you have to use call instruction. When you want to come back, that time you use return instruction. Okay, so in between this, what you do, you just execute your subroutine program and then you can continue with your main program. Okay, so that is the concept of, like you go to you were doing your main function, you were doing your work, but some emergency came, so you have to go, that can be held by only call. Okay, call will execute that, but when you want to come back, that can be done only with the help of return. Okay, and then you can continue your main program. So if you want to go to the call, if you want to go to the subroutine program, then you have to use a call instruction, and if you want to come back from the subroutine program, you have to use the return instruction. I hope you understood. Now let's go with the next instruction, restart. 1 minute. Restart instructions, restart n, where n is from 0 to 7. Okay, the restart instruction jumps the control to one of the 8 memory locations depending upon the number. These are used as a software interrupts or software instructions. Okay, I hope you have seen RST 7.5, 6.5, 5.5 and trap. They are the hardware interrupts, but these you can imagine that they are the software interrupts. Okay, software in a program to transfer the program execution to one or more 8 locations. Control is transferred to the instructions whose address is 8 times the contents of n. These instructions are used with interrupts. As I was telling you, these are nothing but the software interrupts. Okay, now let's take which are the 8 instructions. Suppose example is RST1. Now all the instructions are 1 byte, they belong to register indirect. Now it is similar to what you did with call. Okay, so you were executing something, some program, and then it will just multiply by 8. Like suppose if I write RST 0, so 0 into 8 is 0, that's why it will. Now remember that this address will be taken by whom? Program counter. Program counter will take this address. All the instructions data will be taken, like in this case restart 1, so this address will be taken. Now how they calculate this address is very simple. You have to like 1 into 8 is 8, but what is 2 into 8? 2 into 8 is 16, but this is in hexadecimal numbers. So I think everyone knows how to write 16 in hexadecimal numbers. Okay, that is 10. Remember that this is what 8 3s are 24. So 24. Okay, this is 24. Now 24 they write in hexadecimal as 0020. Sorry, this has to be 0010. This is wrong. This is 0018. Okay, then can you see this is 8 4s are, so you can see this is 8 4s are 32. So 32 into 32 is in decimal, and 0020 is in hexadecimal. Same way 8 5s are 40. 40 in decimal, but 20 like this, they will just multiply by 8. Now why they multiply by 8? Because our 8085 microprocessor is 8 bit, that's why they multiply by 8. I hope you understood this. So there are how many instructions? There are how many instructions are there? Again we got I think 8 instructions. Okay, now the last instruction of this group is program PCHL, load program counter with HL. This instruction moves the contents. It's a very simple instruction. This instruction moves the contents of HL to higher order of program counter, and L to the lower order of program counter. This instruction is equivalent to 1 byte unconditional jump instruction with the address stored in the HL pair. This instruction belongs to register addressing mode and 1 byte instruction. Okay, let's take an example like whatever the contents of H is there will be given to the program counter's higher order, because a program counter itself is a 16-bit. Okay, so load program counter with HL, so it will be whatever the contents will be there of H will be given to program counter higher order, L will be given to the program counter lower order. So I think remember that the contents of HL will not change, only program counter's content will change. So suppose HL is having 2539 before execution, so after execution both will have this address. Okay, HL also and program counter also, because program counter itself is a 16-bit register. Okay, after execution program counter instruction will control the transfer to this address. Okay, program counter, because from here the execution will start. So I hope you understood this. Now this finishes your jump instruction. Let's go with this finishes your branching group of instructions. So jump instructions are 9. This is unconditional and rest 8 are conditional. I hope in the previous session we have already seen this. Okay, then call instructions are also 9. So you can say that 9 instructions have been covered here. Then these are also 9. I think you know that this instruction is used to move the control from main to the subroutine program. Okay, then I think these are also 9. So 9 3s are 27. This is like from subroutine to the main program. Okay, so 9 3s are 27. Then these are 8, and this is also PCHL. Okay, so 8 plus 1 again 9. So 9 4s are 36. So branching instructions total there are how many instructions? 36 instructions. So I think with the help of 2 sessions we have already done with 36 instructions. Please remember that if you know jump instructions, then you can easily understand all the programs of the 8085 TPS or for your board exams. Please revise this, otherwise you will be in great trouble. Okay, I hope you understood. Again and again, please watch the videos. If you are having doubt, you can ask me. Okay, then we'll meet in the next session. Thank you.